Welcome back to Mathematics Through Induction. This is Generalization 5, Roman numeral addition. But before we get to that, let's cover some stuff I talked about in the last video, or maybe stuff I decided not to talk about. We have induced the natural numbers, 1 through onward, however much our system can accommodate. But I've left out 0. The natural numbers, as they're called today, don't include 0. Now, why have I done that? So it's pretty clear why I haven't included the negative numbers, because there's no evidence for them yet. Remember, in induction, we can only base our derivations from evidence, from things you can actually see. And there's really nothing a Babylonian would see right now to indicate negative numbers. But it would seem that you can see nothing. Why don't you just go up to Rom, our fur trader who's invented Roman numerals, go up to him and you say, hey, why don't you write this symbol right here for whenever you don't have any of something? Rom would just look at you and he'd say, why the devil would I ever have to keep track of stuff that ain't there? So you can see there's really no motivation for 0 yet. So as a result, we won't be covering it yet. We only right now, our concept of number is restricted to the natural numbers, 1 through onward. Okay, so let's think about another situation to understand Roman numeral addition. So let's say Rom has moved into the city. He has a nice new shop. His fur trade, he's stacked up enough gold at this point. Now he sells things in his shop in the city. And he keeps track of supplies using his numeral system. So, let's say he has, 12 pigs right now, okay? Then he finds someone who's willing to sell some pigs, and so he buys an additional 8 pigs. So he wants to be able to understand, well, how many pigs do I have now, so I can figure out how many I can commit to selling to people, right? So he simply writes the words and 8 in his Roman numerals, okay? Now this isn't the best way to do it, but this is an appropriate way to represent the quantity. Remember from before, each Roman numeral stands in one-to-one correspondence with either a single unit of the thing you're trying to keep track of, or, in the case of V or X, multiple units, a set number of units of the thing you're trying to keep track of. And so as a result, if you simply write the two quantities next to each other, 12 and 8, then altogether, the symbols before you, the numerals, do in fact enumerate, that's put into numerals, the quantity it is you're trying to deal with. Of course, this way of writing it is not the most efficient way, so we'll condense it. We combine 2 and 3 into V. And then we see that we have XVV. We combine the two V's into X. Those are the relations between the numerals themselves, because we know that 5 tick marks stands in one-to-one correspondence with a single V, and 2 V's stand in one-to-one correspondence with a single X. So the compressions are valid under the old rules. Rom applies those rules to simply write the quantity in a more efficient way. Now, he keeps using this rule. And after a while, he finds that he's sick of writing the word and in between them to sort of tell himself that he's adding them. So he just comes up with a symbol, and obviously I'm going to use our symbol, just to make it easy. So he has this new symbol for adding. And let's do one more example. Let's say that he has 32 gold, and he just made a huge profit. And so he made an additional 33 gold. Here we are. Now he wouldn't call it 33. 3, 10, and 3, right? 3, 10, and 3. So we have 3, 10, and 2 plus 3, 10, and 3, okay? So he lines them all up. We have 5 X's. 5 X's stand in one-to-one correspondence with L. So take away those X's, you got 1 L. We have 1 X left over. We don't bother with him. We combine our 5 1s into a single V. And there we have it. We have 50 and 10 and 5. Now, a general rule here in Roman numeral dealings is that whenever you have a single numeral written 5 or more times, it means some kind of compression is going to be possible to make that easier on your mind, right? So now we've fully understood addition. Instead of having to count upward one by one when you add two quantities, you're able to use the relations between the symbols themselves to speed the finding of the new quantity. So once again, we found that a relation, we've used a certain conceptual construct, these Roman numerals, and the rules inherent in them to bridge that gap in our cognitive abilities. We no longer have to use our limited mind to simply count in one step at a time. We can do the entire set of steps in one mental sweep by combining these units and quickly understanding the new compressed quantity. And so this is kind of one of our simpler generalizations, simple but important, because you can see this, you can see how the logic of one step leads to the next. Now you're starting to be able to see that. Our concepts that we have from the previous steps allow us to figure out new ways of doing things, understand new observations, and come up with new concepts to explain those observations. And those concepts will enable us to understand further observations still. This is the inductive chain. And so to understand this latest generalization, what I want you to do, go ahead and take a look at those exercises down in the description. And something I have to really emphasize, don't do them in your head in Arabic numerals and then write the answer in Roman. It's really easy to do that. I want you to actually go through the mechanics of writing all those Roman numerals together and actually compressing them. Compress those 5 1s into a V, compress 2 V's into X's, etc. Do the whole shebang, do all of those exercises, and that'll get you thinking about Roman numerals, and that will put you in the context of someone in this situation. You'll be able to understand what it means for this to be your most advanced mathematical generalization. And that will enable you to continue on my journey with me and be logical each step in the way, never assuming things that you don't understand or you haven't proven yet. All right, so hope you join me next video as we do, of course, Roman numeral subtraction.